Well, we're back again. The area between two curves, part two. You'll notice that the formula looks identical pretty much to what we did last time, except see the y's and the dy. So what does that mean? Well, this is when we're going to put things on their side. So let's say I have a line, and that's kind of a reflected backwards square root function. And further, let's say I want to find the area right here. So this is my line, y-axis, x-axis here. This is curve 2, and I want to find the red area. Now, this is not really, you can't really go top to bottom here. It's naturally set up from a right and left perspective. So to do that, everything is turned on its side. See, if I were to rotate this 90 degrees, see how this would be the top and this would be the bottom. One way to look at it is like this. When you're going with the y-axis, big numbers are up here and small numbers are up here. So I do top minus bottom. But when I'm looking at it sideways, big numbers are on the right and small numbers are on the left. So instead of top minus bottom, it's right minus left. It's big minus small. That's really the pattern. So this is going to be the rightmost function minus the leftmost function. And then we're going to have to be a little careful on finding points of intersection here, but we'll get to that in our next example. All right, so I'm going to erase this. Now let's actually try this problem. If this line is, let's say, that doesn't give me enough room. The line is 4 minus 2x. Now that would be the square root function reflected about the y-axis there. So there's that equation. Now I want to know that area. So I look at it and I go, okay. In this case, this region will begin, and I don't go from my x's because this is my low y value. See, when this is a dy, this controls, people tend to ignore this part of an integral, but this controls what you're using here. This is in terms of y, this is in terms of y. This is now your low y value because it's a dy integral, and this is your high y value. So this would be my lowest y, which would be 0. And this would be my highest y. Now in this one, there's no point of intersection, so the teacher or the textbook would have to tell you. And let's say, I don't know, let's say we want to go up to 4. Y equals 4. So we'll put a 4 right there. Now, the way we did it last time, it was top minus bottom, but we're looking at it sideways. So the top, it's actually big minus small. This is the big side. So the line goes here minus the curve goes here, right minus left. But I cannot just put 4 minus 2x minus the square root of minus x, because this is a dy integral. So I do need the line, but I have to fix it. So let me get rid of this here. I really don't, this board is so small. I got to get rid of the main equation. I know I need the line here, but I can't use x's. So I'm going to write f of x as y. And what I have to do is I have to solve this for x. So I have y minus 4 equals minus 2x. And if I divide everything by minus 2, I would have x equals minus 1/2 y plus 2, right? Y over minus 2 plus 4 over 2. That is the line solved for y. So I have to put negative 1/2 y plus 2. That is the same line solved the other way around. I just solved it for x instead of solving it for y. That's weird, and that takes people a while to get used to. But see, all this time we haven't been too worried about what this is right here. Students tend to ignore that part of it, but this demands that this be in terms of y, so we've got to fix that. And we also have to do that here. So our second equation is y equals the square root of negative x. So if I square both sides, I'm looking at this. And so x has to be negative y squared. So I have to do the right function minus the left function, but I have to do it in terms of y. That is going to trip people up, so you got to be careful there. So here's my setup equation. There's a lot of thinking that leads up to the set. Once you get the equation, that is the easy part, because you can just chuck that in your calculator. It's getting there that is the hard part. But let's clean this up a little bit. So we have the integral from 0 to 4 of negative 1/2 y plus 2 plus y squared dy. So I'm going to grab my calculator. Now when you put it in your calculator, you can just enter all these in as x's, just switch the variable. But when you set it up, you have to pay very close attention to your x's and y's. So I'm putting in my calculator negative 0.5x plus 2 plus x squared dx. And the calculator is saying 25.33. That's going to be units squared because it is another area. So that would be our first example. It didn't naturally form points of intersection, so I gave those to you. The hard part really is adjusting to this dy stuff. So we're going to go with another example. And it's kind of visually clear, but now it's going to start getting interesting how we got to input things in a calculator. So I got to erase this. Just going to get rid of that here. So what we're going to do is we're going to do a parabola on its side and another parabola on its side, like that. And actually, let me do it like this. We'll use different colors. So I had something like this. Now in this one, it kind of jumps out at you. I think we're going to want this area. Now we could not go top to bottom. This causes major problems. If I were to cut this right at that vertical line where the points of intersection occur, notice my top function is red and my bottom function is red. So I don't care what it is. If you take something away from itself, it's going to zero out. Whatever the function is, anything minus itself is going to be 0. If I get over to the green, green minus green is going to be 0. So we absolutely cannot do this problem from a dx perspective. You got to flip it on its side. Because now the green is always on the right. That's always the big boundary. And the red is always on the left. The red is always the little boundary. So I have to give you some equations now. Now these are not functions. They failed the vertical line test. Nonetheless, red is the equation x equals y squared minus 3. And the green is x equals 4 minus y squared. So that's all I have to go on. I want that area. There's the equations. So I go, okay, let's just start with setting up my integral. Well, I don't know where they intersect. Here's the 2 dots. And I'm going from this is my high y, and this is my low y right here. So I don't know what those are yet, but there they are in the picture. And I'm going to go right, which is 4 minus y squared. Fortunately, it's already solved for me. Minus the left, which is red. So that's going to be y squared minus 3. Now, if I do that, I'm going to get it wrong because this is multiple terms, and that minus has to impact both. You need the parentheses. You got to distribute if you're doing it by hand. If you put it in a calculator, you've got to put the parentheses there. All right, well, that wasn't so bad. I mean, this is pretty much all set up. I could mop this up a little bit. So this is looking like minus 2y squared. 4 plus 3 is 7, so plus 7 dy. That didn't feel so bad at all. I need the points of integration, or the limits of integration. Well, that's the tricky part, because your calculator is not set up to take x equals. When you put this in your calculator and you press y equals, it's y equals. So you've got two options. The harder option would be to solve these for y and use your calculator. The easier option would be to do this. Two curves intersect. I don't want to word it that way. Let's put it this way. You find the points of intersection. Like when two curves are crossing each other, by setting them equal. To each other and solving. Right? And I've hammered on that before. That is an important idea. If you want to know where things meet, you set them equal to each other and solve. And these don't look too bad. So let's try to do this mechanically by hand instead of resorting to technology. You can do it on the calculator, but this is going to be easier. So if we just set them equal to each other, I'm going to move this term over and get 2y squared. I'm going to move this over and get 7. So y squared is 3.5. So all I got to do is square root that. 3.5 square root. So I'm going to get y equals plus or minus 1.87. There's the minus. And there's the plus. And that's getting kind of sandwiched in there. So let's just go back to that version of the equation, right? So that's it. That was much easier to do by hand. Now, it may be that when we do a problem, you're going to want to be able to put this in the calculator, and we'll maybe have another lesson for that. But for now, I think we should just look at set them up and go this route and solve it by hand. Let's just crank out this answer, and we'll finish up this lesson. So I'm doing the integral, negative 187 to positive 187. And that worked out to negative 2x squared plus 7 dx. So I'm getting 17.46 units squared there. All right, so I know that this one might be more challenging than the last one. Remember, you got to try. Try to do the problem. You can go back and watch this video again. Try to look up some other videos that go through it. Maybe you can find something that's a little clearer or gives more examples than I just did. And remember, you can put questions in the comments, or you can send me an email or through Schoology saying what you're having trouble on, and we can discuss it further. If I get enough questions, I'll do another lesson just on the particular questions I'm being asked. All right, well, give it a shot. Take care, and we'll talk again soon.